The history of Irish research is one that is at times linked to our nearest neighbour. But the Dublin Institute was one that allowed Ireland to emerge as a leading international research institute in its own right. We have populated that with both Irish people and with internationally renowned people. It has been an exemplar of the way that institutes deal with other institutes around the world. It puts Dublin, it puts the Institute at the very heart of international research.
Tá Scoilan Lane Celtic bun ó chrothagéim an devaléire an Institute Ard Lane, cho fada siar le naidíag agus lahad leis le 8 na Institute Ard Lane. Agus sa tréimh sé idir an dáirín tá ahantas agus seasamh buinteach ag an scoil mar phríomhbunad an Lane Celtic fuair a domhain agus mar cheann chearú dearmid the Leon na Gaeilge in Éireann go háirithe. Tá an tahantas agus an seasamh atá ag an scoil bunathe an obair bhí an arsúlainte. Agus tá gnéthaí ag súla buint leis an obair sin dearmid cuasaí fáilte cháinir a ggéadal síos, cuasaí taide agus an soláthar a dhéanamid de Locht an Lane go idirnáisiúnta bhuidim scoileanna saoraigh seminéir cógálacha bliantúla agus mar sin. The publishing program has been responsible for the publication of some hundreds of titles since the foundation of the school. We have a program which is self-financing in that our new publications are financed by the income from earlier publications, and we have an obligation under the Act to keep our publications in print. So that aspect of our work is very successful, and of course our publications reflect the the research work that's done in the Institute, which is many-faceted.
The main idea is to use 3D laser scanning technology to, as accurately as possible, represent the Orm stones and their inscriptions. We have a stone here from Ballinanig in County Kerry, which has inscription on 2 angles, and you can rotate the stone so that you can see the inscription, the whole inscription, from side to side, and also you can rotate the stone so that you can see the top of the stone. So an extra feature of this particular stone is the simple cross low down on the opposite side. So we're very excited about this, the potential for this project, and we hope that it can continue.
Irish Script on Screen is a manuscript digitisation project. It was started by the School of Celtic Studies in 1999 and has continued ever since. What it aims to do is to display digital copies, digital images of Irish manuscripts cover to cover on a dedicated website, isas.dis.ie. In fact, the case could be made that the images are sometimes better than the original because you can magnify them. They are magnified and you can magnify them more. You can cut and paste, things you shouldn't do in a library. And generally it's extremely user-friendly. These manuscripts, you must understand, were relatively hidden and concealed and accessible only by scholars prior to this, and people who know where they are and know how to get at them and know what's in them. Now, in the true spirit of digitalisation, these books have been liberated and they're free to peruse and to read if they can, or to read the commentaries on them by everyone and anyone all over the world.
We use physics to understand the whole universe, how it works. We don't do laboratory experiments, but we use the universe, the cosmos, as our laboratory. So we both look downwards to work out in geophysics what's happening under the Earth, and we look up to see what's happening in the furthest reaches of the universe. To some extent, the job of an Institute for Advanced Studies is to be a sort of expeditionary force going out and probing at the boundaries of what is known. It's not our job to do sort of routine research. We're quite clearly mandated in the Act to do the cutting edge stuff. And that of course means that it's a relatively small and specialized group of individuals doing quite unique things. The type of work we do is done in big international collaborations, and we are members of several of the leading collaborations in the world at the moment. We're members of the European HESS consortium, which does imaging atmospheric Cherenkov astronomy in Namibia. We're members of the Japanese Astro H mission, which will be launching a major X-ray satellite in the near future. We're members of the Kilometer Cube Net consortium, looking to construct a deep underwater neutrino telescope in the Mediterranean. And we're members of the MIRI consortium, building an instrument for the next generation space telescope, the James Webb Space Telescope. And all of these things are major international consortia. The type of science we do could not be done without these international collaborations. And I would like to think that one of the functions of the Institute is actually to act as an ambassador for Irish science and project basically the fact that we are doing world-class research on the world stage. So, I mean, we wouldn't be doing our job if we weren't in these international collaborations, in my view.
So in astronomy and astrophysics, what we're doing is considering the birth and the death of stars. So really two extremes. Today we're involved with a number of missions. For example, the James Webb Space Telescope that will actually replace Hubble. Hubble's not going to last much longer. Astronomy, I suppose, in many people's eyes is very much blue skies type of research, but that's not actually true. For example, we're looking for very faint galaxies. That's very difficult, but the same software is now used for looking for breast cancer at a very, very early stage. And who would have thought of that?
We use world-class telescopes to look at very distant clouds of gas and dust where young stars are just beginning to shine. For example, the very famous photograph called The Pillars of Creation is a photograph taken with the Hubble Space Telescope, and it shows very high columns of gas in which young stars are just beginning to emerge and be born. And we are looking at the process of the star formation to try and understand what's going on. And it transpires to be a very violent process in which jets are actually propelled from these young stars at very high velocities. And we're looking at these jets with world-class telescopes to try to understand what these jets are doing. The benefit of this research to Ireland is that it really brings Ireland centre stage in international research, raises Ireland's profile, and attracts very top quality scientists to Ireland to work in these research institutes with other collaborators in Ireland.
There are three major international projects in which we are involved. The first one is the HESS, High-Energy Stereoscopic System of Gamma Ray Telescopes, located in Namibia. HESS is now recognized one of the best 10 astronomical telescopes in the world. And the second one is the project is called Kilometer Cube Net. It is a project for detection of neutrinos, and that is one of the major projects in Europe for astroparticle physics. Third one is a project in X-ray astronomy called Astro H. This is a Japanese satellite, and the project is funded by Japanese and American NASA. And Astro H will be one of the major developments in X-ray astronomy over the next 10 years.
We use physics to understand the whole universe, how it works. We don't do laboratory experiments, but we use the universe, the cosmos, as our laboratory. So we both look downwards to work out in geophysics what's happening under the Earth, and we look up to see what's happening in the furthest reaches of the universe.
even though we know basically the fundamentals of how the Earth works, we don't know the details. We know how ocean crust is created and then consumed, but we don't know how the continents are formed. We don't know why they're so deep they are in some places and so thin they are in other places. And in order to understand the Earth we live on, and it is the Earth we live on, we have to use these methods of physics to get better understanding of the processes that are involved. And I'm a specialist, though, in another science where I use electromagnetic waves, the waves you're seeing me by, except at very low frequency. And they're like radar, but even much lower than radar. And so I can use these waves that propagate into the Earth, and I can see down. The deepest I've seen is 1,200 kilometers. My predecessor, Brian Jacob, he was one of the principal drivers behind seismic studies in the offshore, the Atlantic offshore of Ireland in the mid-80s. And as a direct consequence of Brian's work, we are in Ireland, can now lay claim to a landmass that is 10 times the above sea area of Ireland, because we can show that continental velocity rocks extend way out into the Atlantic Ocean.
This records earthquakes from around the world on a 24/7 basis, 365 days of the year. And that data is then made available to international seismological agencies that want to use it for research. We use it for our own research and for our PhD students and for our postdocs as well. But in order to, if you like, underpin the kind of work we do, we have an outreach program which explains to the ordinary person in the street the kind of work that we actually do in the Institute. And so we have developed the Seismology in School, Seismolíocht School program. And that's been extremely successful in bringing to the notice of students and teachers, especially around the country in both primary and secondary schools, what the whole science of seismology is about and what a dynamic place the Earth planet is. So basically the school involved in the project would have its own seismometer, and in the Institute we act as consultants to the school in relation to promoting seismology. And so when an earthquake occurs anywhere around the world, I get notified from an international agency in Potsdam University and pass on the details of that earthquake to the school. And once the teacher receives that, well, then a lesson starts in relation to where did the earthquake occur? Let's have a look on the map to see where that is in the world. What was the magnitude of the earthquake? How many people were killed in this earthquake? Have earthquakes happened there before? And so we encourage students to write a small report as an essay for the school, or indeed a small report and a picture for a local newspaper, just to highlight their involvement in the science.
One can use MT to image from tens of meters below the surface down to 300 kilometers below the surface and deeper. I guess the common theme running between all of those three renewable energy or sustainable energy projects is that we're using magnetotellurics to map the depth, extent and the properties of rocks in the subsurface. And these are rocks that might provide the basis for geological storage of carbon in one case. In another case, an opportunity for deriving geothermal energy from the rocks. And in the third case, the opportunity for providing storage reservoirs for compressed air energy storage.
The greatest ideas in physics of the 20th century were Einstein's theory of gravity and quantum mechanics. We still do not know how they fit together. Einstein didn't like quantum mechanics. He pointed out difficulties with it, which really baffle our understanding. But that's exactly the properties of quantum mechanics, which we now plan to use for a quantum computer. Exactly Einstein's weak points of quantum mechanics should be transformed to one of the major tools of the future in computation.
I'm working on a problem called Nam's conjecture, and it's a problem that originally comes from physics. It arose in the study of conformal field theory, but actually recently it's been related to quite popular things like string theory and M theory, and they're two of the candidates for kind of a new theory of everything. So it is pretty important in physics, and any work we could do on Nam's conjecture would have kind of wider applications. It would be, have applications in conformal field theory, in string theory. As well as that, and the reason I really like working on it is that while it's a problem that comes from physics, it's also related to maths. And not only is it related to maths, but it ties together some very different and kind of very interesting in their own right parts of maths. Okay, the idea of a theory of everything, like who knows whether one will be found ever or not, or even whether string theory is a good candidate for one or not. I wouldn't even pretend to know whether it is. But basically, there are lots of different theories in physics. So you have quantum mechanics, for example, that deals with very small things. You have general relativity that deals with, I think, things that move very fast. But you want a theory that actually encompasses both of them, and none exists at the moment.
The theoretical understanding of nature allows you to do many things, but we're not very practical in that we are theorists. We do the theoretical side of it. We try to understand why the laws of physics are the way they are, what is the simplest formulation of the laws of physics. And over the past 50 years, the laws of physics have been honed down to some very simple, from our point of view, very simple structure. So we understand how to write down the laws of physics in essentially one blackboard. If somebody he understands the code in which it's written, and the code in which it's written is quantum field theory. I mean, we wouldn't expect any of the things we do to have any applications whatsoever. I mean, they may do, they may not do, but once you've understood something, it's very hard to know what someone else will understand that makes it practical to them. Who would have known that a quantum field theory, it now is, of course, the basis for what are hoped to be quantum computers in the future. I mean, I'm sliding over many things, but that's the essence of it.
It is a difficult time in Ireland's history, but no more difficult than it was when this institute first came into being. And we hope that over the next few years, the institute will help in bringing forward new ideas, new research, which will again continue to put Ireland at the very forefront of research.